Okay, so I said we would start by having a look at this one here. So we've got, much like the one where we were making a tank out of metal, we've got 600 pi of material to make this closed cylinder. So I sort of said, right, start by calling that R and that H. The surface area of this is made up of 3 bits, isn't it? We've got 2 circles and we've got the beam tin lid. So the area of the circles are pi r squared each. Just remind me, Arthur, how long the label is on that, you know, if we think of this as being the label, how long is it? Or how do I work it out? What dimension in relation to the circle is that? So that is this thing that I've opened out flat.
The diameter?
It's not the diameter, circumference. Yeah, it goes all the way around the circle. So it's the circumference, which is pi times the diameter, but we're only dealing with radius here, so I'm going to write that as pi times 2r, which we often write like that. And if we're calling that the height, and that's the height. So what I've got is my surface area is 2 lots of the circle, 2 pi r squared plus 2 pi rh, and that equals 600 pi. Not a particularly nice sum, but there's plenty of simplification that we can do. So, for example, Lewis, what have all 3 of those terms got that we can dispense with by dividing by pi? We can divide everything by pi. I said, you know, can't divide by this, can't divide by that. We can't divide by things that can be 0, but pi is pi. So, yeah. Is there anything else, Ollie, I can divide by to make it all a bit simpler? Perhaps looking at the numbers rather than letters. 2, yeah, divide everything by 2, then. So we're left with r squared plus rh equals 300. Now, sure, what's our objective at this stage of the problem? I mean, we're trying to make the volume equal to this. What am I trying to do here?
Solving for.
What have I? What? Yeah. I've got height in this expression, no height in that expression. So what I really want is to be able to say, right, h is something. So hopefully you can see what I need to do there. I subtract the r squared and then divide by r, and I could just write that as 300 plus r squared, sorry, minus r squared over r. I'm choosing to divide by r separately. So then that's my height. So I'm going to sort of hit the reset button at that point, because what I'm actually after is an expression for the volume. So my volume is going to be pi r squared h, that's the volume of a cylinder. You'll note that we're not given that formula. That's one of those things that we're expected to remember. But h we've just worked out. So it's pi r squared times 300 over r minus r. Two things there. Okay, that's 2 terms, isn't it? So when I multiply this bracket out, I'm going to multiply this by that and that by that. And again, I'm hoping that a few of you feel proof relief at this point, because if I do that times that r cancels out with one of those, so I get pi r times 300, or 300 pi r. And that times that gives me minus pi r cubed, as required. Bingo, we're there. Now, obviously, given that the surface area is fixed, if I make it have a bigger radius, it's going to have a shorter height. And so you can fiddle around with the dimensions And what we're after is the maximum volume. So if I differentiate this, I'm going to get dV by dr. Normally it's y and x. This is dV and dr. So r is my x. So Harrison, what do I get if I, well, answer me this. What would I get if I had differentiated 300 pi x in a normal expression?
300 pi.
300 pi. So this is going to be just the same. 300 pi, that's right, yeah. And Max, if I multiply by the power and reduce the power by 1, what's that term going to become?
Minus 3 pi r squared.
Fantastic. Fantastic, yeah. We want to know where that reaches a maximum, so we want to know the turning point for this formula for volume. So we're just going to ask, when does that equal 0? And I'm going to leave you there to carry on with that one, not now, but in your own time. It's quite straightforward from there. It's quite straightforward. If you make it equal to 0, you can then actually take that over to the other side, divide by pi, divide by 3. It all ends quite happily. So there we go. And that exercise, you know, there's some other quite fiddly questions, but there's also 2 modelling questions on the homework that I sent you yesterday. Make that your first sort of focus. No assessment for this topic, but make that your first focus. Right, so this point, I've attached that to the email. Okay, right. So it's linked in the description below, as they always say. This is a question which looks a bit like a modelling question. Actually, it's not. Actually, it's not. So why am I doing it now? Well, I just wanted to make you get better at recognising, you know, which technique to use when. So have a little look at this question. Now, I have to say, the first thing I would probably do, if I was answering this question, is I would sketch it on my calculator. And I would use GSolve to tell me this value, and that value. Now, I'm not allowed to do that as part of my answer, but I think that might help me a little bit. So can I encourage you to do that and use GSolve to work out where this, and this are. Obviously, this is P equals, so you'll have to, it'll be Y equals when you type it in. The axes, you'll have to work out how to scale them. It's clearly going up quite high, so I might have to go sort of manual here. So I'm going to set my x-axis to go between 0 and 20, and my y-axis I'm going to go from, well, probably not 0 because I want to be able to see the bottom, so I might go from minus 10. I'm going to go to 400 just to see what that looks like. Right, so I've gone too far, that's fine. So let's go back to V window, maybe set that to 200. You can't always get what you want by just using the plus and minus buttons. Right, so now I'm going to use GSOM. Okay, so I've effectively answered the question, although I haven't done any maths. I've just used my calculator. So what we really need to do now is fill in the gaps. So see if you can now do a little bit of maths to get somewhere with that question. You know, we've probably answered a number of them, but can you sort of justify it using some proper maths this time? Excuse me. Right, I'm going to interrupt you. So I've firstly made an attempt to properly locate the roots. I've already worked them out. And to locate the roots, you need to solve the quadratic when it's equal to 0. So I took the version they'd given me, which is completed square form. This is completed square form. I multiplied out the brackets, multiplied it all out, and then used my calculator to solve it. I know it's a weird world where you're allowed to use your calculator for that, but we're not allowed to use our calculator for this, but you know, there we go. So the roots are at 13 and 5. So my answer to part A would be 15 is after the profit falls below 0. There's a root at x is 13, 15 is not a sensible price for selling toy because it will give you a negative profit. Of course, you could have just substituted 15 in, see that you get a negative value. That would have been a quicker way of answering it, but I'm trying to justify my roots. Find, according to the model, the least possible selling price for the toy. Well, that's the other route then, isn't it? You know, if you sell the toy for £5, £100, you're going to make 0 profit. So that would be the least possible selling price. So, you know, I've earned myself 5 marks with that effort. It's quite a lot on an A-level paper. And then state according to the model. Now, it's interesting that it uses the word state. That's a key command word which indicates you really shouldn't have to do any calculation. And that's because this form, and do you notice how I've rewritten it? This happens regularly where you get something like that which just doesn't look familiar, but if I write it like this, it looks familiar now. I know that when you take x squared and replace it with x minus 9 squared, the maximum moves forward 9 units. And it's an unhappy cubic, it's a quadratic, so I know it's this shape. And multiplying by 6.25 doesn't change the location, that just makes it skinnier. Adding 100 lifts it up to 100. So I can just look at that, and that's why they're using the word state, and say the maximum profit is 100 when the selling price is £9. And if I wasn't sure about that, I've got it from my graph. Yes, have I made a mistake?
No, I'm just wondering because of the wording of the question. For B, at the beginning it says, given that they made the profit when they died.
Oh, all right, have I made a mistake?
So would you have to shift the...
So you're absolutely right, I have made a mistake, thank you. So 15 is inappropriate because of it being after the root, but you're absolutely right, thank you for pointing out. So 80,000, so the profit is in thousands, so it's there, isn't it? So yeah, what we've got to do, well, you tell me, Laura, what have I got to do?
I haven't actually got down to it, but...
Sorry?
I just know you have to...
Well, I found these points by asking when is y 0.
Yeah, you have to find when y is 80.
So I'm going to take 80 away. So it's going to be thank you, I completely missed that. I'll biscuit you up any minute in a second. So I'm going to change my, that's going to be minus 486.25. Right, so the roots change. It's money, so it's £7.21. £7.21. And of course we can confirm that with our graph by just adding the y equals 80 line on there, and then gsolve intersect, so that gives us the values that we're after. Thank you. So that question there, sorry, the thing at the bottom is for later in the lesson, so that's not me. I think that's not part D. Yeah, so we answer that without having to do any differentiation. You could have differentiated it because it's a turning point. So you could have differentiated this and found the turning point, but I think that's a whole lot harder than using what we know about quadratics to solve that one. So that wasn't a modelling question. Okay, we're going to move on. I'm going to pause that while I get myself straight. Okay, so the story so far with statistics, if you remember, we looked at mean and standard deviation. So to find the mean, you add up all the data and divide by the number of values. And then the standard deviation was this calculation that works out on average how far away values are from the mean. And we use the mean of the squares, that's the values all squared and added together divided by how many there are, minus the square of the mean. And rather than using the mean, I use the calculation for the mean. And that's called the standard deviation. And there are slightly different formulas, aren't there, for a frequency distribution where you have sigma xf, sigma x squared f, sigma f, etc., etc. Before you square root that, it's called the variance. So the variance is without the square root, the standard deviation is with the square root. We square root because, if you remember, it's about how far values are away from the mean. And we get around the thing that some are bigger and some are smaller by squaring them so that they're all positive. We add them together and average them that way, but then we square roots to get a more accurate value. We then did median and the quartiles, and you know, we did a whole variety of stuff to do with that. So what I want to talk about today is a nice easy break back into it, which is to talk about outliers. Outliers are what science refer to as anomalies. And I love outliers because basically what happens if you've got a set of data and there's a value that doesn't quite fit, you generally just ignore it. Oh, that's really nice. Life would be really simple if I, you know, if that paper on the in the A-level maths was too hard, I'll just ignore it. I won't do it. I'll just do the answer. Yeah, but it's not strictly true. But an outlier is a value that doesn't quite fit with the rest of the data, and there is no definition. There is no standard definition for what an outlier is. So any question that talks about an outlier, and we're talking here about values which are either much smaller than all the other values or much bigger than all the other values, any question to do with outliers would tell you what the definition of outliers is in that question. So in this first example, and you've got a copy of that data at the bottom of that sheet that I gave you, in this case, an outlier is an observation that's 1.5 interquartile ranges above the upper quartile, or 1.5 interquartile ranges below the lower quartile. And so we're asked to see if there are any outliers in this set of data. So this is a good way of revising finding the median and interquartile range. Now, there's 30 females, and they've already put them in order for you. So that makes it quite easy. Well, should do. So go on, just see if you can find the median, the lower quartile, and the upper quartile for that set of data. Okay? Have a go. Have a go. So you've got a copy of it. It's at the bottom of the sheet. At the bottom of the sheet that we just did. Okay? So it's... Please don't write it all down, unless you want to. It's funny, I did my favourite game this morning with Year 11, although I haven't quite got the Year 11 group. I can quite do it the same way as I did it with some of you. So, where's the median? Yes, we didn't have any simple sound effects or anything. It was all a bit. So do you remember, Ben, when you've got a set of data and you're trying to find the median, you've got this problem that with 5 values, the median's the third. That's nice and easy. But with 6 values, it's between the third and the fourth. So it's not just as simple as dividing the number of values by 2. It doesn't quite work. So do you remember that rule? So if you want to work out where the median is, you say, right, how many values? 30. 30 plus 1, 31, divided by 2, 15.5. So I know the median is between the 15th and the 16th value. Assuming that, this is one set of data, by the way? Yeah. So it's halfway between 3.8 and 3.8, which is 3.8. You've then got 15 values below the median. 15 plus 1 divided by 2?
8.
The 8th value, therefore, we call our lower quartile, so that's the end of the first quarter of the data. And the 8th value after the median Of course, oh, Macy's not here, so she's. I wonder if this might be a good opportunity to knock up a box plot. Question doesn't say, but box plots are on the syllabus, and you know, just for kicks. So we've got values between 1.7 and 5.1, so you know, I might. So a box plot, if you remember, has got the median in the middle, so 1, 2, 3, 5, 3.8 with a nice thick line. You then have the lower quartile and the upper quartile. And then you've got a line going down to your lowest value. And a line going up to your highest value. So, with this question, the definition of an outlier is 1.5 standard deviation, 1.5 interquartile ranges above or below the upper or lower quartile. So the interquartile range, I mean, are we happy with the way I've done the lower and the upper quartile? I always start with the median, and then I find the median of the values below the median, and the median of the values above the median. So my interquartile range is 0.8, 1.5 times that is 1.2. So outliers are values which are more than 1.2 away from my lower quartile. So my lower quartile is 3.2. So outliers are any value outside of that. So any value below that is an outlier. 1.5, 1.2 below the lower quartile. And similarly, this is 4.0, so any values bigger than 1.2 above the upper quartile will also be outliers. So, do we have outliers? Yes, we do. 1.7. 1.7. 5.1 is just okay. It's yeah, bigger than the vast majority of the values, but it's not big enough to be a problem. So, okay, I said we just ignore outliers. There are two things we do with outliers. So if we find an outlier, it might be valid. Okay, so for example, if we did a survey of ages of people in this room, there is an outlier. Okay, but my 52 years is not invalid. That wasn't a measurement that was made incorrectly. That's appropriate in the context. Okay, so sometimes outliers are valid. There might be a blooming good reason why. Okay, in which case we leave them. You know, in which case we leave them. But they might be invalid. So they might be, we made a mistake in our measurements, or we wrote it down wrong. We meant to write down 17 and we wrote 1.7. Or the machine might have broken, whatever machine it was measuring. And if it's invalid, then we take it away. And that process of taking it away is called cleaning the data. Now, we've used that phrase before when we were talking about the large data set, because there's situations with the large data set, aren't there, where you don't get a result. There are some NA results in there. For whatever reason, the machine wasn't working that day. So we have to take those out. And then there's the TR values, the trace values, that we replace with zeros. So this is the same sort of thing. We don't necessarily remove outliers because they might be a jolly good reason, but we often take them out, and that process is called cleaning the data. Okay, the definition of outliers varies. So here, an outlier is a value that's 2 standard deviations or more above the mean, or 2 standard deviations or more below the mean. We're given the summary statistics. So we can work out the mean, that's all the values added up divided by how many values there are. And we can work out the standard deviation. So this is a good revision for finding the mean and standard deviation. You don't need to do any adding up because they've given us the values here already. And we know that our calculator would tell us those values, but see if you can spot if we've got any outliers using this definition. Okay, so using this definition. You haven't got a copy of this data, but using this definition, can you identify any outliers in that set of data? This time it's in relation to the mean. Yes, sir.
Do we use our rounded standard deviation or our exact standard deviation?
Good question. I would not use my rounded one, but I suppose eventually you've got to round it. What do they do?
I would use
No, they use a rounded value. Bad maths. I mean, actually, it doesn't change the answer. I suppose the question is, would using an unrounded value change the answer? And in this case, it doesn't. Because that's exact, I'm not, I can use that straight away. So 32 is an outlier in this case. Okay. Now we don't know. We don't know whether you do just get, you know, obese African giant land snail. I mean, they're already giants, but you know. So we don't know whether 32 is valid or whether that's a mistake or an error or some such thing. So we can't say that. But that's an outlier. Right. So let's just practice this then with a couple of questions. One of which you might with start now, and the other I encourage you to finish. You know, we've got this same problem of I've only got a few textbooks, so this is page 43. I think was it page 43 or 44? 43, 3 and 4. Can I just point out, it tells you the variance. Remember, the relationship between variance and standard deviation is the square root of the variance. So start them now, and then you can finish them independently.